Scientists, what do you know that would blow a regular person's mind? Geneticist here. Different people have different forms of various enzymes, meaning that medication is horribly, awfully imprecise and affects people differently. For example, some people break down codeine into morphine very quickly, which can result in a far too potent dose, and some people hardly break it down at all, so there's no pain-killing effect. Until very recently, there was no way to know but try it. The lab I worked in developed a way to record the vibrations a caterpillar produces when feeding on a leaf. We found that plants are able to respond to this vibration when it's played back to them. It not only primes their defenses, but they can distinguish this vibration from vibrations caused by wind blowing, insects walking on them, insect mating calls, etc., and they will not prime their defenses to those vibrations. In short, plants don't have ears, but they can still hear? Okay, and what's the point of responding? The caterpillar's eating it, and the plant goes, "Man, that hurts," and the caterpillar keeps eating? It's more like the plant releases toxins for its friend caterpillar to munch on. Exactly, then releases pheromones to the surrounding plants of the same species to do the same, and sends further messages through the underground fungal hi-fi networks. Plants are sophisticated things and are far more complex and active than we commonly realize. Giraffes have to eat from trees that are upwind from other trees they eat from because they release pheromones to warn the other trees. Anything downwind goes into defense mode and releases chemicals that make the giraffe not want to eat from that tree. Funny that animals have to hunt their plants and find unsuspecting trees to eat from. My research involves Parkinson's disease, and recently there's been findings that contracting an infection such as the flu whilst having PD will make the disease progress much faster, as your immune system will kill the brain cells responsible, in a kind of accidental collateral damage response. So we're looking at how some anti-inflammatories could slow the progress of PD by stopping infections from taking their toll. Early days, but very promising. Just started a PhD in astrobiology. Does that make me a scientist? Looking at microbe behavior in low-gravity environments, it turns out that microgravity has a tendency to make them into these superbugs that are incredibly resistant to antibiotics. There's some worry that this will be a pretty big problem as human space exploration develops. Ah, lovely. Yet another reason for me to never go out into the dark, horrifying expanse of space. Honestly, I was already there, you didn't have to keep trying so hard, universe. Here's a bit of psychology, since the harder sciences are well represented in this story group, specifically relationship psychology. It's been demonstrated that there's a particular ratio of positive to negative interactions that help predict the outcome of relationships. Marriages with less than this ratio are far more likely to lead to a divorce. The ratio is roughly 5-to-1. For example, if there are less than 5 compliments you give your significant other for every 1 criticism, then they're more likely to believe that you criticize them more than compliment them. If you have less than 5 good days a week with your significant other for every 1 bad day, then when you think back over your months or years together, you're more likely to think that you have an equal amount of bad days than good, even more bad days than good. The mind-blowing part is really thinking about that ratio and what it means about our memory and perspectives. Ideally, we'd like to think that if we get complimented about as often as we're criticized, we'd remember a balanced mix of both. But the evidence supports the idea that we really take negative words or events to heart, and that it takes a highly disproportionate amount of positive praise or interactions to balance them out. Something to keep in mind when considering both how you feel and how you treat others. Gotcha. So, you're beautiful, you make me happy, your dinners are lovely, I love what you've done with the house, I appreciate you running me a bath, babe, I think you need to lose a few pounds. Upon reflection, I wouldn't dare. I value my life. Dialect continuums in linguistics. Among certain languages, such as the Slavic languages and Western Romance languages, like Portuguese, Galician, Spanish, Catalan, etc., there's no fine line from where one language ends and another begins. However, due to standardization, this is no longer largely the case. Instead, you'd have one language gradually changing into another as you go farther and farther away. Think of it like in Britain, where the further north you go, the more Scottish the dialect becomes, until eventually you have full-on Scots. Sort of along the same lines, I was fascinated to learn that there are regional dialects in British Sign Language. For example, there are 3 separate signs for the holiday, depending on where you are in the country. Everyone always associates dopamine with enjoyable experiences or happiness, but in a certain part of the brain, how much dopamine is released can be calculated as the amount of reward received compared to the amount of reward expected. This is literally a quantitative signal. If you expected there to be 10 sweets in the bag but there were actually 12, then you'd get an increase in dopamine release. but not as much as if there were 14 sweets in the bag. Similarly, if you expected 10 and received only 8, you'd actually get a dip in the dopamine signal, but not as much as if you'd only received 6, and so on and so forth. This is one of those rare examples where a quantitative theory or model, reinforcement learning, can be mapped straight onto a neuroscientific phenomenon.
Is this why people get hooked on pessimism?
Yeah, I mean, if you don't expect anything, you're never disappointed, and thusly don't take dips in your dopamine levels. That's really interesting to me. I come from a behavioral economics background, and that's how they modified expected utility theory with prospect theory. Essentially, we just say that people get utility from changes rather than absolute numbers. For example, someone who received a $2,000 raise last year will be unhappy with a $1,000 raise this year, because even though it's good to have more money, it's a negative change from their expectations. I work with CRISPR-Cas9 system. It essentially allows us to edit the genome, adding or removing nucleotides or whole genes or altering nucleotides. While there were previous methods for editing genome, this one's quite simple. It requires a few plasmids, less than $100, a basic research lab, and someone who can do fairly basic molecular biology research. Researchers in China are using it on humans now for cancer therapy. It also has the possibility for transmitted disease treatment. Additionally, the part I find most fascinating and most scary are gene drives. We're able to use it to kill off all mosquitoes and thus eliminating Zika and malaria in a matter of a few mosquito generations. This would also be theoretically possible for other species that haven't been researched. I have a good one and a bad one. The bad: more than 2 out of every 3 people in the world carry a virus that causes oral or downstairs herpes. The good is that if you genetically remove one of HSV's key genes, GD, you get a vaccine strain that's protected mice against 10 times the lethal dose of the deadliest herpes strains ever discovered. In short, everyone might have herpes, but it won't always be forever. Wow. I knew that a lot of people had those pesky sores, but I didn't know it was that many. Yikes. Here's hoping we all get immunized like our author here predicts. Jevons Paradox. The more energy efficient we make technology, the more energy we actually use. That actually makes a lot of sense now that I think about it. For example, I recently got a new phone that has much better battery life, 3 times the screen use time with only a 30% bigger battery. But despite the energy use being so much more efficient, I use the phone a lot more because I don't have to worry about the battery dying, making my overall energy use much higher than before despite being much more power efficient. Nuclear transmutation. It's 100% possible to turn lead into gold by yanking 3 protons out of a lead nucleus. It was first done in the 1920s. Of course, it's prohibitively expensive and ultimately a waste of money and energy, but it can be done. The alchemists were right. I'm an earthquake geophysicist. I study something most people have never heard of: slow earthquakes. In a regular earthquake, a fault, as in the crack between big pieces of rock, moves or slips very quickly. Typically, an earthquake takes a few seconds to occur. This rapid movement excites seismic waves, which are similar to sound waves that travel through the earth and cause shaking. In slow earthquakes, everything is the same except that high temperatures or fluid pressures cause the speed of fault slip to max out at a fairly low value. So we might get movement equivalent to what we would see in a magnitude 7 earthquake, but instead of occurring over seconds, it occurs over weeks, months, or even years. The slowness means no seismic waves and no damage. In fact, the traditional instrument used to study earthquakes, the seismometer, won't see these. So we use scientific-grade GPS instead and literally watch the rocks move. Unfortunately, slow earthquakes, while they relieve the forces where they occur, actually increase the probability of regular earthquakes on other faults or other parts of the same fault. There are actually documented cases of slow earthquakes triggering regular ones. The Great Tohoku, Japan earthquake of 2011 actually started off 2 weeks earlier with a slow earthquake. I'm working on trying to find ways to use slow earthquakes to forecast regular ones. Feto-maternal transfer. I learned about it in a neuroscience class. Especially when a woman is pregnant, stem cells can travel from the fetus to the mother and actually survive for long periods of time in the hippocampus, an area of the brain used for memory formation. I'm pretty sure the stem cells can survive in other parts of the body, but it's really cool to think that some of your DNA is in the part of your mother's brain where new memories are formed. In short, stem cells from a fetus can get transferred to the mother's hippocampus, the part of the brain responsible for forming new memories. I remember a Radiolab episode about this. They told the story of a woman who had stem cells from a failed twin who she shared her mother's womb with. Some of those cells became ovaries. Later, when she had a baby, they found that while he was his father's son, she was not genetically his mother. Many animals use the location of the sun in the sky for navigational purposes. Many, but fewer animals use the way sunlight is polarized as a proxy for the location of the sun in the sky. This allows for a mental compass and is how many animals keep moving in their required direction. And many, although fewer again, animals use the moon for the same purpose. However, only one known species, the dung beetle, uses the way the moon's light is polarized to keep rolling their dung in straight lines. However, when the moon is absent from the sky, the beetles default to using the location of the Milky Way in the sky for navigation. 15 days of the month of October, from the equator, we have both the moon and the Milky Way out of vision of the beetles. For these 15 days, they roll in almost random directions, during which they turn frequently and just generally look kinda drunk. You can submit your own stories to be featured here on the channel. The story submission link is in the description below. And if you want to listen to some vibey music in the background, check out easymode, also linked below, and subscribe. Tropospheric ducting. Shortwave radio signals up to about 30 MHz, which bounce off a layer of charged particles in the atmosphere and are reflected back down to Earth, which is why you hear so many AM stations at night. Normally, higher frequencies just poke straight through and go out into outer space. But under certain conditions, they pass through a gap in one layer, hit another, and bounce along between the two, like when you get the ball trapped behind the bricks in Arkanoid, until eventually it bounces back out hundreds of miles away with almost no loss. So by sheer accident of meteorology, you can sometimes bounce VHF and UHF signals far further than they normally go, and they sound like they're just from down the road. So you've heard of stem cells, right? Long story short, cells that can transform into other kinds of cells whilst also dividing and reproducing forever. They're responsible for making new blood cells, driving wound healing, among other things. Really neat stuff. It's now fairly accepted in my field that deadly viruses also have stem cells. We think that these cancer stem cells aren't as susceptible to chemotherapy, and are partly responsible for why the virus seems to come back even after very aggressive chemo. But as to their exact identity, strategies to destroy them, and where they come from, we're working on that. There have been a few posts specifically on stem research, but this is the first one I've seen detailing some of the problems they can cause to the human system as opposed to the cures. Obviously, we should continue to study their medical applications, but it's novel to hear about the problems certain kinds cause that we have to learn to combat simultaneously. Meteorologist here. Upper atmospheric lighting is one of the most seldom understood aspects of meteorology. Above some thunderstorms, sometimes you can spot a jet of blue shooting up from the thunderstorms about 50 kilometers. Even more impressive are sprites, giant red emissions anywhere from 50 kilometers to 100 kilometers above the surface. And ELVs, which is an acronym for emissions of light and very low-frequency perturbations due to electromagnetic pulse sources, which are even crazier. They exist for only a millisecond but can expand to a radius of 400 kilometers from a storm as a very faint red light. Crazy stuff. It's not exactly mind-blowing, but it's a neat and recent finding that might interest anyone who keeps up with the vaccine topic. Post-mortem brain examinations of kids on the spectrum has shown improper cortical distribution. A little background, the layers of your cortex are established very specifically before birth. If you have a healthy brain, you will exit your mother with a clearly defined cortical distribution, and that layer differentiation does not continue post-birth. Thus, we can conclude that the disrupted cortex structures being found in autistic children cannot be attributed to vaccines, which are administered after birth. Furthermore, we can also conclude that autism begins affecting children in the womb. For reference, cortical and cortex are synonymous. C-section babies are, on average, less healthy and have more compromised immune systems. This is likely because the birth canal is smearing the last bit of mum's immune system programming before breast milk, as well as helping create a healthy bacterial environment for the newborn. Essentially, a mother's walls on the birth canal are coated in things that will help the baby adjust to life outside the womb. C-section babies are starting to get the benefits of this, with the doctors wiping the wall fluids onto the baby's face, mouth, and head. Flashover and backdrafts are pretty cool and terrifying. Basically, flashover is when you get to a point in a compartment with a set amount of ventilation where the heat release of the fire reaches a certain kilowatt and every combustible in the room ignites almost simultaneously. It's really freaking hot, and it's really, really bad to be caught in. Backdraft is when there's a lack of oxygen in a compartment with no ventilation. The hot gases build and build and build, and then when oxygen is reintroduced to the building, it explodes in what is basically a fireball. Violently. Scientifically fascinating and also horrible to be a firefighter in. Surface science. Van der Waals forces between material are almost universally attractive, but it's possible to create a three-material stack of a surface, an intermediate, which is a liquid or potentially a thin film, and a contacting material that has a repulsive interaction, meaning that the surface and contacting material will repel each other like two north ends of a magnet. Applications would include surfaces that would be water, oil, dirt, a biohazard, or whatever proof, and frictionless interfaces, tested by AFM and undetectable at the pico-Newton level. Unfortunately, the thin films required are not easy or cheap to make, and development would be really, really expensive. Not quite mind-blowing, but definitely exciting. We now have microscopes that can achieve resolution in the low nm range in living cells. We can now start to research the dynamics of small subcellular organelles that are important for a wide range of things, such as embryonic development, cancer progression, and cell signaling. I'm a dentistry student, and yesterday a paper was published where a group of scientists managed to use an anti-Alzheimer's drug in order to build new dentin in damaged teeth. Pulp tissues are already capable of doing that, but new research is desperately trying to find agents that can speed up the process. So this is great news. Giving a person superpowers in VR, for example the power of flight, will prime concepts of superpowers and the heroes we associate it with it, and will increase helpful behavior. Long story short, there was a study wherein people had to fly with a helicopter or use hand gestures, like Superman, to fly in VR. After the experiment, the conductor accidentally spilled a pen case. The people flying like Superman were significantly more prone to jumping in and helping the conductor to pick up the pens. I really like the idea that the people tend to have the desire to use their powers for good rather than to go full-on supervillain. There's a documentary that's been released lately, and it's called Most Likely to Succeed. It's about a new education method where it's 90% project-based. The teachers don't do much other than just let the students do their projects and give guidance, as well as organize what projects to do. It's a unique way of teaching that only works in specific schools. Some teachers and members of society think it's the greatest idea and every school should be using it. Me and other teachers don't see it as straightforward as it seems to be. I would recommend giving it a watch, though. I live and study in Denmark, and to my knowledge, at least universities here, I don't know about high school, have an 80% project-based teaching. I moved here from a country that's 100% focused just on theoretical approach, and you just need to read and remember what you read. I can say in my case that project-based learning is way more efficient. That surprises the narrator not at all. Give me a concrete goal and clear steps to achieve it, and I will shine and complete stuff before the deadline. Give me a big, vacuous subject to find out information about and read about in my spare time, and my motivation will be very poor indeed. Right now, as we speak, you're being crossed by millions of particles per second and per centimeter square of your body. These very same particles will be able to fly across the Earth as easily as if they flew through a vacuum. In fact, to reliably stop them, you'd have to build a 3 light-years thick lead wall, i.e. a wall that would be 2/3 of the distance between the Sun and Alpha Centauri, the nearest star. Said particles are electrically neutral. They don't interact through nuclear force and are 100,000 times lighter than an electron, or perhaps even lighter. Yet we can detect them every day. Neutrinos are cool. Pretty much everything about sleep is terrifying, most of all that we don't really know what it is or why we do it or how it works. Why do you sleep? Because you get tired. How do you sleep? Well, here's a list of things that change while you sleep. What is sleep? When you aren't awake. What I find most disturbing is sleepwalking and parasomnias. Watching people sit up during a sleep study and finding out that they're still asleep. Opening their eyes and looking around, and then usually they pick at the wires, maybe lifting them up and tugging on them, or touching where they're placed on their head. And that's not even the really creepy part. That is that they don't pull them off or anything. Instead, I've so far only seen them all do the same thing. They give up. Like, you can read the facial expressions saying, "Screw it, this is too complicated for me to deal with," and they just lie back down and don't go back to sleep because they didn't wake up. They just close their eyes. It's not that the lights are on but nobody's home, it's the lights are on but you aren't in there. I mean, I'm not really a scientist, I'm just a lab tech, so maybe there's an explanation that makes it less disturbing. I'm not a scientist, but I've studied sleep and have on occasion sleepwalked. Your lower brain, active during sleepwalking, is quite capable of performing basic tasks without your conscious input, such as standing up, walking around, peeing, and so on. However, your cognitive maps are stored in your upper brain, which is needed for the complicated stuff. Sleepwalkers are generally trying to realize an external goal, such as needing the bathroom, eating due to hunger. However, without the upper brain, it makes a best guess, which is why it's common to hear about sleepwalkers getting up in the middle of the night and urinating on chairs or anything that might remotely resemble a toilet to something that doesn't know what a toilet is. In your example, I suspect the lower brain is trying to remove the wires, as I assume that the body might have a problem with things sticking onto it, such as, for example, leeches. But it lacks the cognitive ability to comprehend what's going on, but is somehow satisfied that there's no threat, so it doesn't boot the upper brain and goes back to sleep. Trees suck up water. Most people know that, but what blows my mind is that they don't have to be alive to do it. Dead, standing trees still suck up water. It's a structural component, not an active function of the living organism. Also, there's way more water from snowmelt than we ever thought there was stored in trees, based on a recent isotopic study of Alaska forests. Malaria parasites have shown resistance to every single anti-malarial drug in existence and can develop resistance before new drugs are even finished in trials. Not that there's a big push for anti-malarial drug development. Last I checked, there were 7 new drugs for male member dysfunction in the pipeline for every anti-malarial, and 64 drugs for heart disease. A problem a lot of people in malaria-endemic countries would be thrilled to live long enough to have. That about 1% of the noise you see on a TV when it's not tuned, the black and white dots with the horrible noise everyone hates, is the interference from the cosmic background radiation, the leftovers of the Big Bang. Some people know, but it blew my mind as a kid, and now I'm a physicist and it still does. Galaxy lensing. I think it's just beautiful. Just like the way a magnifying glass works to make things appear bigger, large chunks of mass in our universe, like galaxies, have a strong gravitational pull over large amounts of space that focuses light, giving a distorted look, which leads to some special cases. It often results in an Einstein ring, but not in all cases. This phenomenon has been used to probe universes and can give good insight into finding better measurements on the Hubble constant, without local contamination like many other methods. The Casimir effect. Simply put, if 2 unchanged plates are brought very close together, due to the presence of virtual particles, the plates are forced together. Only smaller wave functions can fit between the plates, meaning less virtual pairs are created there, creating a pressure difference between the inside and outside, forcing the plates together. When you subscribe, make sure to hit the bell to turn on notifications. Put the playlist on in the background to finish listening to all the stories, or if you want some vibey music to put on in the background, check out easymode. If you like Am I the Genius, give Am I the Jerk a shot. Everything linked in the description.